Okay, starting our new unit, we have to make sure that we have all of the foundation skills mastered with angles and knowing how to classify angles and identify what angle measurements are just by looking at them. So, lesson 1, classifying angles. It's the start of geometry. Geometry is everywhere, by the way. You see it everywhere in this room, outside, everywhere. Geometry is absolutely everywhere. You can identify all types of angles and shapes and degrees everywhere you go. I'm going to start with one angle, which is nothing new to you. This was introduced to you in elementary, an acute angle. I like to say it's so small it's cute, which means it's less than 90 degrees, okay? Your right angle is a 90 degrees, and it's known with a little square in the corner. It's exactly 90 degrees. So an acute angle, if we were to draw this line here and it looks like a 90-degree angle, it would be smaller than 90. I always say it's so small it's cute, right? To me, this looks like it's about a 45-degree angle because it's less than 90, okay? That's a right angle. And then we have obtuse, okay? Obtuse, if here was your 90, it means it's bigger than 90. And actually, obtuse angles are between 90 degrees and 180 degrees. So not between, or it's not more than 180. It's actually called something else, but we don't need to know that yet. It's between 90 and 180. So if I were to draw that 90-degree angle right here, okay, that would look like maybe 120 degrees here. If I were to draw that right angle here, that's definitely around 45 degrees if that right angle was right there. So that's acute, right, and obtuse. There's one more. New this year, a straight angle. And it looks like a line, okay? It doesn't look like an angle at all. It's actually looking like a line. It's exactly 180 degrees though. So if I were to draw this in half, what's half of 180? 90. And what does 90 and 90 make? 180. It's a straight angle, okay? A straight angle. What angles even are? Angles are met at a vertex. So like right here, right here, right here, and right here. Those little dots are called a vertex, where two lines meet. That's technically what an angle even is. Now I'm going to give you some vocab. I shouldn't say quite a bit, but more than usual. You need to know this term, congruent. Write it, underline it. Congruent means that the angles have the exact same measure. Underline same. Keyword same. Okay? That means that two angles are the same measure. Or not just measure, they might have the same length, side lengths. Like if that one's 2 inches, that one's 2 inches. So it's not always measure, it's also length. It means the same. Here's another 7th grade vocab term is vertical. What are vertical angles? Vertical angles are opposite of each other. They are opposite angles. I'm going to show you what that means in a second. And then one more is called adjacent. They're not opposite of each other, but they share a common side. Angles that share a common side. Okay, so there's some vocab for you. I want to talk about an intersection that we're all familiar with. I'm going to go ahead and say the Thompson Road and Torrey Road, right? Like we could walk there from here. I'm going to go ahead and draw that, an intersection. So are you. I'm going to say that one's Torrey Road, and then this guy's going to be Thompson. So here's Thompson Road. And this guy right here is Torrey Road. And there's an intersection. And I'm going to say right now that is definitely a 90 degrees, okay, all the way around, 90, 90, 90, 90, like most intersections are. Let's see, what's on the corner over here? I think it's like Fenton Lanes, the bowling alley. So Fenton Lanes is over here, the bowling alley. There's like an abandoned bank type building right here. We're just going to call it the bank. We don't know what it is, but it looks abandoned right now. And then we have over here that it looks like a giant barn made for storage. We're going to call it barn storage. And then right here, it's either the Beacon Bridge, A&W, that gas station. Let's just say A&W. Okay. So that's on the corner. So let's go ahead and talk about these vocab words using the angles. So a vertical angle. are angles that are opposite of each other. For example, the barn storage angle, I'm going to highlight it, is opposite of A and W. It's not necessarily across the street. So follow my pen. You would think, oh, we got to cross the street to the bank. No, those are not opposite of each other. The barn storage is opposite of A and W. Okay, you got to walk kind of kitty corner. So maybe also write that in parentheses. It's kitty corner. I'm also going to say the example here of where barn storage is vertical. I'm going to abbreviate to A and W. You can also say Fenton Lanes is vertical to that abandoned bank. That's vertical of each other. Vertical of each other. They're opposite of each other. They're vertical of each other. A and W is vertical to barn storage. That abandoned bank is vertical to Fenton Lanes. Okay, adjacent. They share a common side. So right here, a common side. This is where Fenton Lanes and A and W are adjacent angles to each other because they share that common side. So let's write that down as an example. Fenton Lanes is adjacent to A and W. You can also say Fenton Lanes is adjacent to barn storage. Barn storage is adjacent to the bank, and the bank is adjacent to A and W. But Fenton Lanes is not adjacent to the bank. They do not share a common side. They are vertical of each other. Okay, so make sure you understand the difference. All right, this is also where you're going to see protractors, and protractors will help you with a lot of noticing and identifying angle measurements. Okay, so this is what a protractor looks like. And this is also a tool when you work on it online. And I do have some provided for class, but just not a whole class set. All right. You can also locate these at the dollar store. They're cheap. So this is what they look like. Going back up here, I want to talk about these angles one more time. If I were to put this these are called crosshairs, on the vertex of where those two lines meet. So like right there, you see how I'm trying to line up my line with the line that I drew? And it does look like it's going straight through to about 45 degrees. What's half of 90? Okay, 45 degrees. Right there, if I were to continue drawing my line between 40 and 50. Now, some people get confused and think, well, why isn't that 135 degrees? It is if it's an obtuse angle. So if I were to draw my angle like this and go this way, then you have to use the top measurements. Okay? So if I were to shift over to this obtuse one, put the crosshairs right there, okay, there's 90 degrees, right? If I were to continue my line, goes 90 degrees. Oh, if I were to do 120, that's right here. I'm going to say it's a little more now, so 124. Okay? And over here, I'm not 54, 120 degrees without line, all the way through. Because I'm saying more degrees, more than 90 measures. Okay? Over here, it's you. Change my line, here. Okay? 45 degrees, sorry. Now, please stop this way. Okay? It's not so right there, 7 8, that's the line. Right? It's not like I do right. Now, look at 180 degrees. I'm going to go okay? Right here, it's a straight angle. It's 180 degrees, 180 right there. Right? 180, or 90 degrees. Whatever it is, I'm going to say, oh, I'm going to 60 degrees. Okay, 60 degrees. Use like this little arc, put it at an angle, 60 degrees. Before I go to protractor right here, you should know that if a straight angle equals already 180 degrees, well, 60 plus what equals 180 degrees? This is where they say you need to solve for the missing measure, x. And again, it's like saying 60 plus what equals 180. If you said 120, you're correct. You can check it with the protractor, okay? And you would have from 60, you can count, okay, 120 all the way up down to 180. All right, and that's exactly what we have here. And it's the opposite of what you can see that's left on the obtuse angle, 120 degrees. Now, if you don't know that, you can use all the skills that I also taught you last chapter with equations. 60 plus x equals 180. I see a positive 60, so subtract 60 from both sides. X equals 120, doesn't it? Don't forget to label your answers. So I just showed you multiple ways to solve for a missing measure. It's not always that easy. I want to go ahead and draw a figure over here, and so are you. Okay, these are not 90-degree angles. I'm going to give you, this guy here is going to be 55 degrees. And I'm going to say this one, is which means that it's acute, right? It's less than 90. This guy is going to be obtuse. He's 125 degrees. And this guy over here, I'm going to say 5 times x amount of degrees. And we're going to use all of what I just taught you up here using our vocab and our equation laws with finding missing measures to find x and to identify what's vertical, adjacent, and congruent. Well, just by looking at this figure, if this side's 125 degrees, you need to prove what's congruent of it. Well, what angle is vertical of this 125 degrees? This guy over here. That means he's also 125 degrees because if they are vertical from each other, they are congruent. They are the same. Which means that if this guy's 55 degrees, this guy's also 55 degrees. So if you're solving for x and you see a problem that says solve for x of this missing measure, well, 5 times what equals 55? And you should all say 11. Okay? So it's like 55 plus x equals your 180, by the way. Because if this was a straight line and this was a straight line, straights equal 180. 180. If you want to check it, go ahead and subtract 55 from both sides. And x equals 125 degrees. That's what we have here to prove that these two are congruent and vertical. These two are also congruent and vertical of each other. And that's finding missing measures using the vocab, congruent, vertical, and adjacent angles to prove that they are the same, congruent, or what x equals.